This will be the last video for section 7.1. We're going to cover this integral right here, which shows us very little information. You'll notice the dx over 1 plus cosine x, that you can't use a u sub because your u would be 1 plus cosine of x, and then you'd have to have the derivative of cosine, which I don't have on top. So it really doesn't leave much for us to even consider. However, the method in the textbook, it just says multiplying by 1. I don't like that particular phrasing of the rule. This rule is more considered the conjugate. So what you'll do is you'll add, I shouldn't say add it, you'll multiply by a 1, but you'll multiply by a 1 in such a way that the top and the bottom will be manipulated. So in this case, I'm going to multiply by the conjugate of the bottom. Now this can happen with radicals, this can happen with trig functions. Those are the two most common functions that you're going to have to deal with when multiplying by a conjugate. When multiplying by a conjugate, what's nice about the conjugate is that when you multiply all of these pieces, again foiling out the denominator, what you're going to find is that the 1 and the 1 will be left, the cosine and the cosine squared will be left, but all the middle terms will disappear. So if you're again willing to do that, I'm going to have 1 minus cosine of x plus cosine of x, and again those two terms will cancel out, and then finally minus cosine squared x. So these two terms in the middle here will just simply cancel each other out perfectly, leaving us with 1 minus cosine squared. So this integral becomes the 1 minus cosine x on top. Don't forget your dx. We're going to move that off to the side again. This dx we're just going to move off to the side. And it's going to be divided by 1 minus cosine squared x. But let's recall that if I've done this correctly, then again, if it's trig or if it's radical focused, then this denominator piece that we just used the conjugate on should simplify or manipulate into something more efficient for us to use. And in this case, hopefully you were thinking this is the same thing as sine squared x, based on the Pythagorean theorem that is 1 equals to cosine squared x plus sine squared x. Again, you might have seen that in different forms, but that's the first Pythagorean identity in trig. We have to make sure we review those. There's two others based on secant and tan, and there's one more based on cosecant and cotangent. So I'm going to be left with that 1 minus cosine of x dx, and hopefully at this point your thought process is, well, maybe if I just go ahead and manipulate this and distribute that sine squared to both sides. And that's really what we're going to do next. So if we can't go from here with a u sub, which again, u letting equal to the denominator doesn't really work efficiently, letting it equal to the top means that we can't have anything group up with that dx. So my next step is treat this as though it's a rational function with a single termed denominator. So this gives me the integral of 1 over sine squared x minus the cosine of x over sine squared x dx. So I'm going to treat this as though it's two separate integrals. This right here is going to be the integral of cosecant squared, which if we recall should be one of the formula rules that we remember from calculus 1. The integral of the derivative of cotangent is cosecant squared with a negative in front. So that means that the integral of cosecant squared should be cotangent of x with a negative sitting in front. This one over here, I'm going to go ahead and manipulate a little bit more with the trig identities. Again, I'm doing nothing but manipulating these based on our trig rules from pre-calculus, and we should have hopefully practiced them a little bit in Calc 1 because they're coming back now. So when I manipulate this one, we'll see that we have a cosine over a single sine, which provides me with cotangent of x. But then I have, again, a singular sign left in the denominator. But a singular sign left in the denominator is nothing more than a cosecant of x. So you'll notice now that we have negative cotangent cosecant all inside that dx. And this should, again, come back to you as one of those derivative rules. The derivative of cosecant was cosecant cotangent with a negative in front. So that means when I'm integrating cotangent cosecant, I should get back a negative cosecant. With this negative out in front, it changes that to a positive, and therefore we end up with this, with a plus c attached to it. Again, starting from up here, it was multiply by the conjugate. Here is algebra. Here is trig identities. And then from here to here is remembering your basic derivatives from Calc 1. So again, if you struggle with your derivatives from Calc 1, it's a good idea to make some flashcards for yourself and go through those and review them. So on a recap, in terms of what we've done in section 7.1, we first started with basic u substitution. We then identified that fractions of fractions, cause us lots of issues, and the most efficient way to try and integrate those is by manipulating the secondary fraction, the denominator or the numerator where there's already another fraction. The two examples we didn't cover were rational functions with long division, as well as splitting the fractions up, which is again just this example here. And then in the last video we covered complete the square. So make sure you know all of those specific methods of algebra. Those are all algebraic methods that will simply make the integral look nice for us to hopefully know what integral we're playing with and then integrate to the final solution.